Astronomers have identified a possible planet orbiting the star 40 Eridani A, which is famously known in the Star Trek universe as the home star of Mr. Spock's fictional planet Vulcan. However, new research suggests that the detection might be an astronomical illusion caused by stellar vibrations and oscillations. A team led by Abigail Burrows from Dartmouth College, who previously worked at NASA's Jet Propulsion Laboratory, published a paper titled The Death of Vulcan, NEID Reveals Planet Candidate at HD 26965 is Stellar Activity in the Astronomical Journal. Note, HD 26965 is an alternative name for the star 40 Eridani A. The initial announcement in 2018 about the possible detection of a planet orbiting a star made famous by Star Trek sparked excitement and interest. However, within just 5 years, other researchers questioned the planet's existence. Now, precise measurements using a NASA-NSF instrument installed atop Kitt Peak in Arizona seem to further confirm that the Vulcan planet belongs to the realm of science fiction. Two primary methods are used to detect exoplanets, planets orbiting other stars, in the ongoing quest for new worlds. The transit method, which monitors the slight dip in starlight as a planet passes in front of its star, accounts for the majority of detections. However, the radial velocity method also plays a significant role in exoplanet discoveries. This method is particularly important for systems with planets that do not transit in front of their stars from Earth's perspective. Scientists can measure the wobbles in a star caused by the gravitational pull of an orbiting planet by tracking slight changes in the star's light. While radial velocity signals often lead to definitive detections for large planets, smaller planets can be more problematic. Even the scientists who originally reported the possible detection of the HD 26965b planet, quickly compared to the fictional Vulcan, warned that it could be stellar vibrations masquerading as a planet. They reported evidence of a super-Earth, larger than Earth but smaller than Neptune, orbiting a sun-like star approximately 16 light-years away with a 42-day orbit. However, new analysis using high-precision radial velocity measurements, which were not available in 2018, validates the cautionary note about the possible discovery. The disappointing news for Star Trek fans comes from a device known as NEID, recently added to the telescope complex at Kitt Peak National Observatory. Like other radial velocity instruments, NEID relies on the Doppler effect. Shifts in a star's light spectrum reveal its wobbling movements. In this case, disentangling the supposed planet signal from light emitted at various wavelengths from different levels of the star's outer shell, photosphere, revealed significant discrepancies between individual wavelength measurements, Doppler shifts, and the combined signal. This likely indicates that the planet signal was actually caused by something oscillating on the star's surface with a 42-day rotation period, possibly related to convection beneath the star's surface, churning layers of hotter and cooler material, with features like bright, active regions known as spots and plages. Both can alter a star's radial velocity signals. While the new finding effectively eliminates the possibility of a Vulcan planet orbiting 40 Eridani A, at least for now, the news isn't entirely negative. The demonstration of such fine-tuned radial velocity measurements promises sharper observational distinctions between real planets and the tremors and jitters on distant stars' surfaces. In the Star Trek universe, the destruction of Vulcan was also anticipated. Vulcan was first depicted in the 1960s original TV series as Spock's home planet. However, in the 2009 Star Trek film, the Romulan villain Nero uses an artificial black hole to destroy Spock's homeworld.